Okay, now what we got going on is factoring. And so that's going to be huge till, well, this chapter, the next chapter, and a whole bunch in future chapters as well. And so learning how to factor is critical, and it's basically unmultiplying. So what we learned in chapter 4 was about polynomials and how to add polynomials, how to subtract polynomials, how to multiply polynomials 2 sections worth, right? And how to divide polynomials. And factoring is actually just unmultiplying is what it is. So we're going to be looking, so this is our beginnings of chapter 5, and we're going to be looking at 5.1 here. So the chapter 5 notes and 5.1. And they first tell us what the definition to factor means. It means to write as a product. An equivalent expression of this type is called a factorization of the polynomial. And so we actually already factored numbers, right? I don't know if you guys remembered, but we'd say something like 8, and we would say, well, that could be written as 2 times 2 times 2, right? So that was a way of factoring 8, to write it as a product. Now they're going to be looking at polynomials, like a binomial like this, and asking you to factor it. What you want to try to factor out of a binomial, if you're given this, is the greatest common factor. And so most people call that the GCF, greatest common factor. Between two terms is the largest factor they have in common. In other words, it's the highest term that divides both terms evenly. Now, one way of finding the greatest common factor is to factor the monomials into pieces. So to take this monomial, this is a binomial altogether, but this is a monomial minus a monomial, right? And to take 12 and to write 12 as 2 times 2 times 3. And I'm thinking about my primes when I do this. 2, 3, 5, 7, 11, it goes on, right? 13, 17, 19, etc. Okay. And then I'm going to write this as y, 3 y's, y to the third. So this is times y, times y, times y, minus, and then 3, well, that's just 3 times y. And they're only asking us to find the greatest common factor, and this is only one way of finding it. So there are other ways of finding the greatest common factor, and all you have to do is circle what they have in common. So they have a 3 in common, and they have a y in common. And so all together, the greatest common factor is the things that you circled. So here I circled 3y, here I circled 3y. So what they have in common, the greatest common factor is 3y. So there are some common factors that are not the greatest. So common factors means it divides both of them. So 3 is a common factor, but 3y is the greatest common factor. And y is a common factor, but 3 times y is the greatest common factor. And so if I said that it was 3 or y, not 3y, I would be naming a common factor, something they have in common, but not the greatest thing they have in common. Let's try this one, just so that we can see. And I'm still on factoring them, the pieces. This is a trinomial. And I'm still on factoring the pieces. So 6 is 2 times 3 times A, 3 of them, B, 3 of them, right? And you get where you just think this. You don't write it. 12 we learned over there was 2 times 2 times 3, A, B, 4 of them. Minus 8 is 2 times 2 times 2, right? I did that up here. Times A, B, right? And then I want to circle what they have in common. That's what I'm going to do next. And so I notice that, well, I thought they had 2 in common, and they do. They have 1, 2 in common. So they have a 2 in common. So I'm going to circle what they all have in common, a 2. They don't have a 3 in common because 3 doesn't go into 8. So they don't have, and they have one A in common. This one has just one A. So they have one A in common. One A in common. It doesn't matter which one I circle, one A in common, but I want to circle something on each one of them. And then they have three B's here, and they have more than three B's here and three B's here. So in common, they have three B's, B to the third. Doesn't matter which three you circle. Then the greatest common factor is just what you circled. And every single term is telling you it. So you can look at any of them and it'll tell you the greatest common factor has a 2 in it, an A in it, and three B's. 2AB cubed. So just my list of common factors, just so that you can see the difference between the greatest common factor and just common factors, right? 2 is a common factor, and A is a common factor, and 2A is a common factor, but none of these are the greatest common factor. And 2AB is a common factor, and B is a common factor, and 2AB squared is a common factor, but not the greatest common factor. The greatest common factor is 2AB cubed. And there's dozens of other common factors that I could name that I haven't named here, and I'm asking you for the greatest, the one that has the most in it, right? And so, so this is the greatest common factor. And these are common factors, but not the greatest. Okay, and then the greatest common factor doesn't have to be, this is already pulled apart. Well, you could pull it apart more if you wanted. You could write this as 2 times 2, x times x minus 3. So this is the one term, right? Remember that right there, I know that if I distributed, it would be more than a monomial. But right now, it's acting like a monomial because it's times. 4x squared times x minus 3. So right now, this is acting like one term. And this part over here is acting like one term as well. So if you wanted to 3 times x minus 3. And do you see what they have in common? They don't have a 2 in common. They don't have an x in common, but they do have the binomial x minus 3 in common. So the greatest common factor, and they only have one thing in common, is this binomial x minus 3. The greatest common factor is x minus 3. So I guess the point is that, and that's a binomial, right, is that they can have a binomial in common. And so anyway, so that's kind of our story there. And so what we want to do with the greatest common factor is we want to put it in the front. That's what we want to do with it. And we want to unmultiply. And so I'm just going to remind you of some multiplying that we did in chapter 4. So in chapter 4, they told us multiply. And then what we would do is we would multiply 11x squared times x, right? 11x squared times x. We'd use the distributive property. And so this is 11x to the, remember you add the exponents, 3, right? 2 plus 1 is 3. And then 11 times 12, so a positive times a negative is a negative. And then 11 times 12, I think, is 132. It's one of the ones I try to know. And so, but I haven't done it in a long time, 11 times 12, so maybe I'll make sure. You can always check with your calculator. Checking with your calculator is a sign of caring enough to get the right answer, right? And so it's okay to give a try and make sure that it worked. Okay, so this is what they asked us to do in chapter 4, is they asked us to multiply. In chapter 5, what they're going to say to us is they're going to say to us factor. And then they're going to give us 11x cubed minus 132x squared. And we're going to ask ourselves, well, first step, what's the greatest common factor? That's what we're going to ask ourselves. And you could do it by piecing it apart. So 11 x minus 11 times 12. Well, I'm going to break it all apart. I'm going to get crazy. I don't really have to break it all apart, but I'm going to, no, that's not how you do that. You can do it that way, but usually you do a tree, right? 2, and 2 goes in there 6 times 12, 66 times, is that right? 66 plus 66 is 132. Yep. And then this is, so I'm getting crazy, 2 times 33, right? And that's 3 times 11. So this is 2 times 2 times 3 times 11 times x, right? So that I can circle what they have in common. And we already knew because we multiplied this. They have 11 in common, and they have x to the second. They have 2 x's in common. So the greatest common factor is 11x to the second. So I was asking myself, what is it? And this is what it is, and this is one method of finding it. There are other methods of finding it. And so I'm going to put that 11x to the second in the front. That's how you factor out the greatest common factor. Then you put your parentheses for your binomial, because it was a binomial, and you're asking yourself, 11x to the second multiplied by what gives 11x to the third? Well, right there it's telling you it's x. That's what's left over. It's a minus. And then what's left over here is that right there, right? 2 times 2 times 3 is left over. And so I'm not going to circle that because I already circled what they had in common, right? 2 times 2 times 3 is 12. And then no x's. And you notice that we just got back to where we started. And so they are asking you to undo. They're asking you to undistribute. And the first step to undistributing is to find the greatest common factor. And the greatest common factor goes in the front. Then you build it back so that when you multiply it together, it gives you what you started with. So factoring out the greatest common factor is like undistributing is what it is. And we learned how to distribute in chapter 4, right? Maybe even sooner than that, because I know we did the distributive property in chapter 1. So I'm asking myself, what do these have in common? And multiple ways of doing it. So this is for people having their training wheels on, like when you're riding a bicycle, you have your training wheels on, you factor the pieces. So 14x is 2 times 7 times x, and 21 is 3 times 7. And now when I'm asking myself, what is the greatest common factor? That's the first step. I can see, well, what do these have in common? Well, this and this have 7 in common. So what do you do with the 7? You put it in the front. You divide it off to the front, so to speak. So I'm going to circle the 7, and I'm going to pull it to the front. And then what's left over? 2x. 7 times 2x is 14x, right? Getting me back where I started. And what's left here? Well, plus 3. 7 times 2x is 14x. 7 times 3 is 21. And that's all they wanted me to do, is find the greatest common factor. It was 7, and pull it off. So factor out the greatest common factor. So the greatest common factor was 7, and I have pulled it off there. So, and put it in the front. I have undistributed it. And so, and of course I can check my answer by multiplying it back together. Now, most of the time, people get where they don't have to write this step. And I'm totally fine with you not writing that step. And what people say is they go like this. Well, what do they have in common? Well, they don't have, and you attack the smallest number. They don't have 14 in common. And then you start thinking about the things that divide evenly into 14. So you attack the smallest number. And the things that go evenly into 14 are 7 and 2 and 14, right? 14 didn't go into 21, but 7 that goes in, right? So I start thinking about the things that the divisors of 14, right? 14, things that go into 14 are 1 and 2 and 7 and 14. And I already knew that 14 didn't go into 21, doink. How about 7? Does 7 go into 21? Yes. So 7 is the greatest common factor. So people do it that way as well, and then they unmultiply. They say 7 times what is 14? Well, 7 times 2. And I need the x, right? To make 7 times 2x is 14x. Positive times a positive is a positive. 7 times what is 21? 3. And so anyway, so another way of thinking I'm doing it, I'm good with either. I write this for a while until, a lot of people tell me they're bored with seeing it. And you can remember do the video faster if you're already a factorer. And so this is the answer. So when they asked you to factor, that is the answer. This was a different thought on doing it, but not totally different, just a little bit different. So factor out the greatest common factor. Well, the first thing is to find the greatest common factor. If you know what it is, wonderful. If you don't know what it is, if you know what it is, put it in the front and start going. If you don't know what it is, well, let me show you how you can find it by factoring the pieces. So this piece is 30xy squared, and 30, right, I'm thinking about the tree that goes with 30, is 2 times 15, and that's 3 times 5. And so this is 2 times 3 times 5 times x times y times y. Boy, there's the most beautiful bird I've ever seen in my backyard. The other day I was doing a video and I looked out there and there was a raccoon in my backyard. I don't particularly live in a rural location. I wish I did, but I don't. I live in pretty much the city, and so it's kind of amazing to see that kind of thing. 25, well, 25 is just 5 times 5. Times x times y. So what do they have in common? What is the greatest common factor? Well, you can circle what they have in common. They have a 5 in common, and it doesn't matter which spot 5 I circle. So I circled the second one here, and I don't know why I circled the second one. I just did. It doesn't matter. And so you could have circled the first one. They have a 5 in common. They have an x in common. They have an x in common. They have a y in common. This one only has one y. This one has two y's. So they have one y in common. And now they both are telling me what they have in common. 5xy. 5xy is what they have in common. So if you knew that they had 5xy in common, great. And you would have been at this step writing the 5xy in the front. And then you would have been saying to yourself, 5 times what is 30, right? Whereas I'm going to put this together, since I have it, is 2 times 3 is 6 times y. That's what I'm missing on that first piece. Those are the things I didn't circle. Notice when I multiply this and this together, I get that. 5 times 6 is 30. X, but no x to multiply by, so just x. And y times y, add the exponents, 1 and 1 is 2. Or use your fingers. A y and a y, when you multiply them, is y squared. It's a count of how many y's that it is, right? There are 2 y's, so it's y to the second. Minus, because this is a minus. And if you were a person that didn't write this step, you would be saying 5 times what is 25? Well, you can see that the leftover stuff, it's 5 and x. Now, to make sure, and then this is my answer, to make sure that my answer is all done, there's 2 ways that you check. So these are the 2 ways that you check. Number 1, you multiply it together, right? Multiply it together to make sure that it's what you started with. So there's 2 things you have to do to check. And so you multiply it together to make sure that it's what you started with. So it's what I started with. And the second thing, and this is what people don't check, you make sure that your binomial or your trinomial, so this part here, monomials are done. So the 7's done, but this binomial, and this is a binomial here, might not be done. Monomials are done, so 5xy is done. Monomials are done, but you make sure the binomial or the trinomial, make sure, starts with a C? No, it starts with a S. I was starting with a C, I don't know why. Make sure the binomial or the trinomial, whichever you have. I have binomials here, but I think I have an example with a trinomial, has a greatest common factor of 1. In other words, it won't factor anymore. So if I asked you what's the greatest common factor between 2x and 3, well, you would go to the smallest number and you would say, because you're probably saying they don't have anything in common, right? I can't circle anything in common. But this idea of the 1 divides everything, right? So the numbers that divide 2 are 1 and 2. 2 doesn't go into 3, but 1 goes into 3. 1 goes into everything. So this binomial, 2x plus 3, the greatest common factor equals 1 for 2x plus 3. And that's good, because you want the greatest common factor of your binomial to be 1. The only thing that should go into it is 1. So is the greatest common factor of this binomial 1? See how they didn't have an x in common, so they can't have a variable in common. These don't have an x or a y in common, they have different. 6, the things that, thinking about 6, the things that divide evenly into 6 are 1 and 2 and 3 and 6. And none of those things, except for 1, go evenly into 5, right? So the greatest common factor of this binomial is also 1, right? 5, same way, right? It's 1 and 5. And so what do they have in common? What are the things that divide evenly into both of these? Well, only 1. They only have 1 in common. And so, you can't factor out the 1. You don't want to factor out the 1. And so you're just done. But that's what you want to make sure, is that the binomial or the trinomial has a greatest common factor of 1. So if I looked at this, that the greatest common factor would be 1. So everything has 1 in common. So I thought I had a trinomial here. I have to go get a trinomial to factor. And so this is an added bonus. So it's an added bonus problem that wasn't, for some reason, in my notes there. And so we will go and find one. And in fact, I'll get one right out of your book. And so I'm going in the textbook to section 5.1, and I'm going to grab one right out of the textbook. Is my plan. And I'm going to grab number 22. So this is from 5.1, my added bonus, 16x to the 4th minus 20x to the 2nd plus 16x. Okay, and so we'll do the problem two ways. One way I call with training wheels on, and the other way I call after you get where you're kind of going good on it, where you kind of get the idea of what's going on. And so the training wheel way is to factor this piece. And 16, you can use your tree. You get where you can think these things. Hopefully you can. And 16 is 2 times 2 times 2, 4 times. 2 times 2 times 2 times 2. X, 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 X. So there's that piece right there. This is the training wheel method. Fast forward ahead if you don't need the training wheel method. Okay. Minus, and then 20. And so I'm going to prime factor 20 here. 20 is 2 times 10, 2 times 5. So this is 2 times 2 times 5 times x times x. And I'm going to put little green. So this is just the same as that, right? Then I'm going to factor 16 again. Well, I already did that. So plus 2 times 2 times 2 times 2 times x. And then I'm going to circle what they have in common, is my plan. Okay, so what they have in common is 2 2's, right? 2 2's here, 2 2's there. So for 2's, they have 2 2's in common. 2 times 2 is 4. 2 2's in common, which is 4. So the greatest common factor, so far I'm building it, has two 2's. And I see that the limiting factor is 1x. Can only have one x in common because that guy over there only has one x. So x. So the greatest common factor is 4x. And what you're going to do with the 4x is you put it in the front. And then you're going to have a room for a trinomial. And you're going to put in what you're missing. So 2 times 2 times x times x times x is 4x to the third. The sign, minus 5x. And 2 times 2 is 4, plus 4. And then I'm all done, but I need to check, right? And so you check by multiplying it together, right, to make sure it's what you started with. 4x times 4x to the third. That's why we want to make sure that we can multiply from, right, from our previous section, because that's the first step. That's a crazy 5 right there. That's the first step, is to make sure that you have what you started with. So when you multiply that together, you get 16x to the fourth. 4 times 5, crazy 5. So it's a positive times a negative is a negative. X times x is x squared. And then plus 16x. And yeah, that's what I started with. But that's not the only thing you need to check. You need to make sure also that the greatest common factor of the pieces, 4x cubed, right, 5x, and 4, those pieces, is equal to 1. So you need to make sure that the greatest common factor of my trinomial is 1. That's what you need to make sure of. That they don't have anything, no number divides evenly into them other than 1. 1 goes into everything. So they don't all have an x, so they don't have x in common. 4 is the smallest number up there. And the things that divide evenly into 4 are 1, 2, and 4. And 2 doesn't go into 5. It doesn't matter if 2 goes into this guy. We're talking about having something in common for all 3. So they don't have 4 in common because 4 doesn't go into 5. They don't have 2 in common because 2 doesn't go into 5. All they have in common is 1. So that's when I know I'm done, is that also what they have. So that was the method with training wheels, right? And so this is without training wheels. And so this is for people who are have factored before, or pick up things rather quickly, or are just ready to look at it a different way, right? So this is the answer. This was my check that I have the right answer. And so what I would say to myself is I'm supposed to find what they have in common. And so looking at the numbers and the variables separately, the variable is actually easier than the numbers. What variable they have in common is x to the first. Whatever one is the smallest is what they can have in common. So the greatest common factor, that's what I'm asking myself first. I know that it has an x, right? Now I'm thinking about the numbers, 16, 20, and 16. So this is what I think in my head. 16, does it divide evenly into 20? And the answer is no, it doesn't. So I think about all the things that divide evenly into 16. And I think I have a complete list there. So 16 didn't go into 20. Nope. Does 8 go into 20? No. How about 4? Does 4 go into 20? And the answer is yes. 4 goes into 20. So they have 4x in common. What you do with what they have in common is you put it in the front. And then you build this by thinking, when I multiply right there, what would I have to multiply 4 by in order to get 16? And it's 4. And if you're thinking that's division, 16 divided by 4 is 4. You're right. And then I have x to the 1 here. So how many more x's do I need in order to make x to the 4th? Well, I need, remember they add, I need 3 more. So because 1 out here plus 3 more in here make 4 altogether. And then minus, and I'm on 4 times what is 20? 4 times 5, right? I got 1x, I need 2, so I need 1 more. So when I distributed this, I'm getting that. Positive times a positive is a positive, so I need a positive. 4 times what is 16? 4 times 4 is 16. I already have all the x's I need, right? I need 1x. I already have x out. So there you have that. And hot diggity dog, this is the answer, right? And you could do your check the same way we did our check over here of multiplying it back together to make sure. So my answer, my beautiful answer, I'm not going to have those underlines there, but my beautiful answer there. And you can check it by making sure that it multiplies to give you back what you started with, and also that the greatest common factor of your trinomial is 1. Okay, so that was my added bonus problem. And so this was with training wheels and without training wheels, and this is the most common mistake. I can't help myself. A common boo-boo. And I see this all the time, is that people will say that the greatest common factor is something other. So greatest common factor is, and they'll say perhaps just 2, or maybe they'll say 2x. Either way is a boo-boo, because remember it was 4x. And so let's pretend like they just said 2. And then they'll pull a 2 out in the front, and they'll get 8x to the 4th minus 10. 2 times 10 is 20, x to the 2nd. 2 times 8, 16. And they'll check it. And they'll say, ooh, I forgot an x right here. And they'll say, you know, when I checked, and it was when I checked it that I discovered that I forgot that x right there. Just FYI, it happens to everyone. It's when you check it, then you can sometimes catch a boo-boo. And so boo-boos happen to everyone. And they'll say, this is the answer. And they'll tell me, I checked it. I multiplied it back together, and it gave me what I started with. And it certainly does, when you multiply it back together, give you what you started with. But the problem is right here. The greatest common factor between those right there is not 1. It's not 1. And that's the problem. That's why this is not the right answer. The greatest common factor between those, 8 doesn't go evenly into 10, and 4 goes into 8 but doesn't go into 10, but 2 goes evenly into 8 and 10 and 8. So they have 2 more in common, right? And they also have x in common. So really the greatest common factor now here, it should have been 1, but because it's not, it's 2x, right? That tells me I made a boo-boo. This and this, you notice, multiply together to give the 4x, right? And so you just didn't get the whole thing out there. Anyway, so this is the most common boo-boo. To avoid, right? To avoid. You don't want to have a boo-boo. Okay. Now we talked about having binomials in common when we were naming the greatest common factor. And so I have this term right here, and I have this term right here. And you notice that the greatest common factor is a binomial. It's x minus 7. So every time that they ask me to factor, I start with the greatest common factor. So if they ask you to factor, they're showing you what to start with first. You ask yourself, what's the greatest common factor? And here they have a binomial x minus 7 in common right here. Right? So that's, and remember what you do with the greatest common factor. So the greatest common factor is x minus 7. You put it in the front. So there's the x minus 7 in the front. And then you pull off the x minus 7 from both pieces. So when I pull it off, pull it to the front, I'm left with x squared minus 3. X squared minus 3. And then I'm all done. This is factored. You should look at your binomials and make sure that their common factor is 1. So this one has a number of 1. The smallest number is 1. So that's all they can have in common, these two. They don't have x in common. This has a 1, so all they can have in common is 1 for numbers, but they don't have an x in common either. So the greatest common factor of the binomial is 1. The greatest common factor of that binomial is 1, so I'm all done. If you're thinking, well, how do you multiply that back together to make sure it's what you started with? Well, they have held the x minus 7 as 1. So usually I would FOIL this together, but they said hold this as 1, right? So if I'm multiplying to make sure that it's what I started with, I'm going to hold this as one piece. I'm going to hold it together, right? And I'm going to multiply that whole piece times x squared. And whenever you multiply a binomial times a monomial, the order you would write them in is the monomial first and the binomial second. And then minus, right? A positive times a negative is a negative. Monomial is 3, binomial is x minus 7. And then done, right? Second step was greatest common factor equals 1 for your binomials. And we saw that. The greatest common factor between x and 7 is 1. And the greatest common factor between x squared and 3, it doesn't matter if it's positive 3 and negative 3, is 1. So I'm done, right? The terms don't have anything in common other than 1, and so I know that I'm completely done. If I distributed this, and I distributed that, and I FOILed this, they would be equal to one another. Okay, so this one started off partially factored, if you will, right? This was already written as a multiplication, so partially factored. This is another partially factored one. This is one piece right here, and I want to know what does it have in common with this piece right here. And if you're saying, well, they have, right, greatest common factor, that's when I say, what do they have in common? Looking for the greatest common factor, GCF, they have 2z plus 9. I got these lovely pencils, but they're a little bit blurry, I know. So 2z plus 9. And what do you do with the greatest common factor? You put it in the front. So this is 2, I'm going to write my 2 like that, z plus 9. There's my greatest common factor, 2z9 out in the front, z plus, this was my z plus 9. And I'm removing it, right? I'm pulling it off of those pieces. And what do I have left here? I have 3z squared plus, and then you might say 0. And that's a common boo-boo to put 0 there or to put nothing. But when you multiply this together with that, you want to get this. And when I multiply this together with that, I want to get that. So if I put 0 there, it's a common boo-boo. Well, 0 times anything is 0. It's not equal to 2z plus 9. So I want something that when I multiply it by 2z plus 9, I get 2z plus 9, right? I want something that when I multiply 2z plus 9 times this thing, that my result is 2z plus 9. Can you guys think of what that thing would be? That when you multiply it, you get itself. It's not 0. Yeah, it's 1. And so you needed to have a 1 there. And essentially, right, these multiply together to give that. These multiply together to give that. Do they have, so that's the check on multiplying, right? Do they have anything in common other than 1 for the binomial? So I'm putting my finger over this so I can just look at this guy. Does he have anything in common other than 1? And the answer is no. 2 doesn't go evenly into 9, and the only other thing that divides evenly into 2 is 1. And they don't both have a z, so they have 1 in common. 2z plus 9 has 1 in common. What about 3z squared plus 1? What do they have in common? Well, they have 1 in common, right? The smallest number up there is 1. And you can only have in common what the biggest number is. What the smallest number is, that's what you can have in common. and the smallest number is 1, so they have 1 in common. They don't both have a z, so they don't have z in common. And then we're all done. And so that is our answer. So that's what they were looking for. Now, if I look in the back of the book, and I notice in the back of the book that they've written this, 3z squared plus 1. So this is just a note for you, times 2z plus 9. Well, they have the same answer as you. They just wrote them in a different order. But so note, this and this are the same. And so they're equally the same. They're equal answers. I mean, so you can have this or you can have that. Doesn't matter. You don't have to have both, right? And the same here. You can change the order because they're both binomials. So you do write a monomial first and a binomial second. So or a trinomial. So on this, the monomial was written first, and that's the common convention. And the trinomial was written second. So that's great. And on this one, just looking back at things we had, right? Here, monomial times the binomial. That's the convention. And so order does matter here because the size is different. Hey, Sue, you going to teach some math? Big girl, you going to teach some math? Okay. So they give us a factoring strategy, and they give us this factoring strategy every section, and then they're going to put it all together in, I think it's section 5.5. And so right now, the factoring strategy is when someone asks you to factor, the very first thing that you think about is there a greatest common factor for all of the terms? And it might just be that they have 1 in common. If they have 1 in common, then you do nothing. We consider it not anything that we're going to factor out. If they have anything other than 1 in common, we have to factor it out. Then after that, you count the terms. And if there are 2 terms, you do yada yada. We're going to learn that in another video in 5.2. No, 2 terms is 5.4, I think. 3 terms is 5.2. If it has 3 terms, then you do yada yada. And if it has 4 terms, well, that's what we're going to do right now, is if it has 4 terms. So you can see that this one has 4 terms right there, right? And this one has 4 terms right there. And so grouping is something to try. And in our class, grouping is going to do the trick. If it factors, grouping is going to do the trick, but you'll learn more techniques for ones that have 4 terms when you take pre-calculus. And so anyway, so that's the story on that. And so if you can write them in descending order, that's best to do. If it has multivariable, then just leave them in the order that they're in. So this one has more than 1 variable. It has x and b, and so just leave it in the order it's in. Whereas this has 1 variable, so I would write it in descending order, which it is written in descending order. X to the 3rd, degree 3, degree 2, degree 1, degree 0. So anyway, so multivariable, I didn't have that here, but I'll write it here. Multivariable leave alone. And if that doesn't work, then reorder it, but try leaving it alone first. And then you group the first 2 terms and you factor using the greatest common factor typically. Okay, so you group these first 2 terms. Oh, I was going to look to see if it had something in common for all 4 terms. So let's make sure it doesn't first, right? First step, does it have something in common for all 4 terms? So let's try it. So the smallest number up there is 3. And 3 does not go evenly into 4. And it doesn't matter if 3 goes into 15 or 20 because it didn't go into 4. So they don't have 3 in common. The only thing that divides evenly into 3 is 1, right? So I'm thinking about the greatest common factor here. And 1 so far, right? Because 1 goes into everything. So I'm for sure going to say yes to that. Do they have an x in common? Well, that means does every term have an x? So I have a first term here with an x. Does this term have an x? No. So they don't have x in common. That one has an x, but it doesn't matter. Has to be all of them have it in common. That one doesn't have an x. So far, they have 1 in common because they did not have a number other than 1 in common, and they don't have the variable x in common, and they don't have the variable b in common. So the greatest common factor is 1. So you do nothing. And there's a song about that, right? And so then you move on to counting the terms. 1, 2, 3, 4 terms. So you try grouping, because that's what you do with 4 terms. If you have multivariable, just leave them alone, right? So I have multivariable, so just leave it alone. And try grouping the first 2 together. So I'm trying grouping these 2 together, and I'm asking myself, what do they have in common? And so now I'm trying to factor just these first 2. And the first step on factoring is to think about the greatest common factor. And they have in common not a 3, right? Because 3 doesn't go evenly into 4. And they don't have an x in common, but they do have a b in common. So what you do with what they have in common, this is my thoughts, is you put it in the front. B times, and then you can peel it off, right? So get a b off of this one and get a b off of this one. So this tells us 3x minus 4. Then the directions say, so you group the first 2. You can make sure that when you multiply it together, you get what you started with. You can make sure now the common factor here is 1, right? Doesn't have anything in common. You bring down the second sign. So this is the first sign, the second sign, and whatever it is, you just bring it down. So it's a minus here, and when it's a minus, you say to yourself, I'm going to have to be careful. And when it's an add, you say to yourself, oh, it's going to be happy days, right? I'm going to less chance of making a sign error. So I have to be careful because it's a minus. But don't worry, I will. Then you group the second 2. So I'm grouping these second 2. That's minus 15x plus 20. And I want to pull out their greatest common factor. And their greatest common factor, 15 is the smallest number there. And 15 doesn't go evenly into 20. But things that divide evenly into 15 are 5, which does go into 20, and 3, which doesn't go into 20, and 1, which also goes into 20. But I want to get the largest of those, and 5 was the largest of those, right? So 5 is the greatest common factor. They don't have x in common, right? So you put this 5 out in the front. So actually what you're factoring out is a minus 5. And so whatever the leader sign is what you want to factor out. So the leader here was 15x, and it was negative. So I kind of have it as its own little step. Bring down that sign so that you get the right sign out there. And so if you were saying this was minus 5, okay, then put a minus 5 out there. And so you already had the minus out there. And then we're going to put our parentheses, and we're going to be pulling out negative 5 and trying to make negative 15, right? And so we're saying to ourselves, negative 5 times what would make negative 15? Well, a negative times a positive, so this needs to be positive, and will make the sign negative, right? And then 5 times what will make 15? 3. So negative 5 times 3 is negative 15. And then I also need an x. Now I'm working with the sign, so this is where I have to be careful. A negative times what will make a positive? Yeah, a negative. And most common boo-boo is to put a positive here. And so I know that I'm making a boo-boo. I'm making a boo-boo for a point. Boo-boo for a point. To make a point for conversation. And then 5 times what is 24? 20. 5 times 4 is 20. So it is a boo-boo to put a 4 there, because when you multiply this times this, you don't get negative 20, you get positive. You don't get positive 20, you get negative 20, right? So I know I have a boo-boo there, but the point I want to make is that these binomials, right? So group the last 2 and factor out the common factor. We're doing that. Factor the greatest common factor binomial. The binomials must be the same. If the binomials are not the same, find and fix your boo-boo, right? And so here my binomials are not the same. And so that means that I have a boo-boo. And so, and we've talked about the boo-boo that I have. A negative times a positive is not a positive. So this really should have been negative. And now you notice I don't any longer have the boo-boo, and the binomials. Binomials are 3x minus 4 and the 3x minus 4 are the same. So when it says the same in capital letters there, it's not saying quite similar to one another. It's saying the same. And so term by term, sign by sign, the same. Then what you do is you factor out the greatest common factor binomial, just like what we were doing up here. So we were already doing that step a little bit out of context. And so then you say to yourself, well, what do these have in common? Well, what they have in common is 3x minus 4. So what do you do with the 3x minus 4? You pull it to the front, right? Because that's what they have in common. And you're essentially getting it off of this piece, and that piece you're dividing it off, so to speak, right? And so there it is, and I'm dividing it off. And what am I going to be left over with, right? Well, here I need a b, so that when I multiply those together, I get this. And here I need the minus 5. And then this is my answer. And of course, I would want to know how I can check my answer to make sure that my answer is correct. So there's two things that you check to make sure that your answer is correct. You check that when you multiply them together, you get what you started with. Multiply together and get start, what I started with, right? And so in this case, that's 3x minus 4 times b minus 5. If I multiply this together, that's a binomial times a binomial, and I notice I've got 4 terms here, so I'm going to do the FOIL, right, that we learned in chapter 4. So this is 3xb. Normally you would write that in alphabetical order, but they did not write it in alphabetical order, so I'm going to follow them. And then 3x times 5 minus 5 there is negative 15x. And then on the inside, minus 4b. And then on the last, a negative times a negative is a positive. 4 times 5 is 20. And you notice that I've got 3xb, and I got negative 15x, I got negative 4b, and plus 20. And so I have all 4 terms, not in exactly the same order, but order doesn't matter. And because of the commutative property of addition, if I wanted to, I could switch the order here. That would be a fair thing to do and show you, see, it's exactly what I started with, right? And then the second thing you want to make sure is that your binomials and trinomials have a greatest common factor of 1, that there isn't anything that we miss that they have in common, right? And so I want to make sure that the greatest common factor between 3x and 4, that looks like a K, is 1. Well, 3 doesn't go evenly into 4, and the only thing that divides evenly into 3 and 4 is 1, and they don't both have an x. And I want to also make sure that the greatest common factor between b and 5, doesn't matter if I said b and negative 5, it does not matter at all. So it's just the numbers. What do they have in common? Well, one's a b and one's a 5. They don't have anything in common except for 1. 1 divides into b, 1 divides into 5. I'm looking at what divides into both. The only thing that divides into both is 1. So my binomials have no greatest common factor other than 1. And I want to make sure of that, because if they did, I'm not done. So this is problem 62 out of your textbook on section 5.1. And I notice that they're asking me to factor. The first step is to look for a greatest common factor for all 4 terms. So I'm looking for something that divides evenly into all of them. And I notice that they don't have a variable in common, because 21 doesn't have a variable. And 8 is just made up of things that are multiples of 2, because 8 is just 2 times 2 times 2, right? And so if you don't divide by 2, then you won't divide by 4, and you won't divide by 8, right? And 21 is the guy that's sitting there that's keeping us from having a greatest common factor for all four terms, because 12 and 14 do have something in common with 8, but 21 doesn't have anything in common with 8. And so greatest common factor, other than 1, greatest common factor is 1. So that means do nothing. Do nothing to start with. So then you go on, greatest common factor is 1, count the terms. 1, 2, 3, 4. Okay, there are 4 terms, so or more terms. You try grouping. If it's possible to write them in descending order, get them in descending order. Got them in descending order. So you're going to think about the first 2, and you're going to think about what is their greatest common factor for the first 2. Well, 8 and 12 do have something common. They both divide evenly, not by 8, but by 4. And x to the third and x to the second have something in common. They have the smallest of the variable, x to the second, in common. So the greatest common factor for that is 4x to the second. And what you do with it is you put it in the front. So 4x to the second times what is 8x to the third. 4 times 2 is 8. I got 2 x's. I need one more to make 3, so it's 2x. 4 times positive, right, times what is a negative? Well, a negative. 4 times what is 12? Well, 3. I already have all the x squares, so I'm good. Needed x squared, already have x squared, perfect. Bring down this sign, and you smile to yourself when you bring down that sign, because whatever it is what's going to be the sign in between. It's most common boo-boo not to bring down the sign, and so that's why it's a whole step on its own. Bring down the sign. And now I'm looking at, well, what's the greatest common factor? And the greatest common factor is, well, what goes evenly into 14 and 21? 7, right? 14 doesn't go evenly into 21, but 7 divides evenly into 14 and also 21. And so, and they don't have a variable in common. You might be thinking, it would be better if you knew your multiplication pretty good in order to do the factoring. And the answer is, you're right. It would be really good if you knew your multiplication. If you don't, you can use a calculator to figure out what they have in common. You could say to yourself, well, they don't have 14 in common, right? And then you could start backing off of that. Not that it would be very fun, but does 13 divide into 14? No, it doesn't. You could check it on your calculator, right? Just backing off of it take forever, but it's possible. I actually had a guy that had no multiplication skills do this method and got a really good score on the test. But it really slows you down, so you might not have time to finish your test when you're having to do this to see what divides into 14, right? I was on 11, right? And so, I don't know. I maybe instead of doing this, it's quicker to know your primes and then prime factor it. So these are our primes. It's definitely quicker to know your primes. I don't even know why I was thinking that way. Oh, I was timesing. I don't want to times. So does 2 go into 14? Yes, it does. How many times? You could use your calculator. 14 divided by 2 is 7. So 14 is 2 times 7, and 21 is 3. 3 goes in there. So you could try 21. Does it go by 2 if you didn't know? 21, does it divide by 2? Nope. 21, does it divide by 3? Knowing my primes, yep, 7 times. And now I can see what they have in common. They have 7 in common. So you could do it that way. So let's see, 7 times what is 14? 7 times 2 is 14, and I need the x. 7 times 2x is 14x. 7, a positive, times a what is a negative? Well, a negative. 7 times what is 21? Well, 3. And I'm not done. I'm on the last step. Factor out the greatest common factor binomial. The binomials must be the same. And you notice that the binomial 2x minus 3 and 2x minus 3 are the same. So I want to factor out now the greatest common factor binomial, which is 2x minus 3. So this is my thoughts, right? I'm going to put it in the front, 2x minus 3. And then you are literally dividing it off of this term and dividing it off of that term. And what's left over? Well, 4x squared plus 7, right? And then that's my answer. And how you could check your answer is multiplying it together to make sure it's what you started with, right? So you would check next. And also checking that these only have 1 in common. Well, 2 is the smallest number up there. 2 doesn't go evenly into 3, so they have 1 in common. 4 is the smallest number up there. 4 doesn't go evenly into 7. Things that divide evenly into 4 are 2 and 1. 2 doesn't go evenly into 7, so they have 1 in common. So I've checked step 2. The greatest common factor of my binomials is 1, right? And then the first check is to FOIL, right, this, and make sure you get what you started with. So get ahead of me. Our foiling should be top notch right now because we just practiced a whole bunch of foiling in chapter 4. Order doesn't matter, but you want to make sure that you have all the pieces. So 8x to the third minus 12x squared plus 14x minus 21. I could reorder it if I wanted. So definitely this is the answer. It's what I started with. And that, my friends, was the last of that. So hot diggity dog. That was a lot.